The energy for change, innovation, creativity, and ultimately economic growth resides in a highly developed human capital base. The results of the National Critical Skills Audit of 2018 underscored that Zimbabwe, notwithstanding a high literacy rate of 94%, has relatively low average skills availability rating at 38.3%. The National Critical Skills Audit also confirmed the existence of large gaps between the supply and demand for skills in several key sectors. With an overall deficit of 68% in the production of qualified specialists and technicians, especially in the natural and applied sciences, engineering and technology, medical and health sciences, and agriculture.
We need to change the mindset from regurgitating knowledge for knowledge's sake to productivity. We don't want our students to come out of this university with a lot of knowledge, but without practical application in society to solve real societal problems.
We have shifted our curriculum towards more practicals, but those practicals which are meant to impart skills. So we are creating a situation where in the next 2 or 3 years we will start graduating students who are more skilled, who will not be thinking of looking for a job, but start their own small businesses and also create employment in the process.
The National Development Strategy 1 stipulates that improved availability of specialist skills for industry, commerce and public sector will be achieved through realignment of curricula on skills training and development to meet needs of industry, commerce and the public sector.
The framework that we're looking at is to say if we have certain products that we may need for our own local market or even international markets, what we're looking at is to say, what is it that our postgraduate students can actually do, meaning to say looking at what happens at PhD level. If they work on a project, we want to realize how our MPhil students can actually tap into those particular projects. And we can look at it to cascade down towards what happens within our undergraduate programs. So basically, looking at the framework itself, we are looking at research, which actually cascades into research and development. Then we look at innovation. Then we look at prototype development. And then we try to protect our intellectual property. And then from the prototypes that we get, we can actually incubate them within our innovation hubs, where after a certain period of time, after we realize that they can actually have a market value in terms of the sales that we can actually get, we can take them further now to the industrial parks.
This one is a CNC machine, a table CNC machine that we have developed, which we'll be using for prototyping, mainly in PCB, printed circuit board drilling. We also have developed a rolling matrix display, which is ideal for advertising. This one behind me is the display. We are also working on development of inverters, high-powered inverters that will be useful both in energy, both in powering our homes and also a drive for powering irrigation equipment. So the inverter is actually complete. We're about now to roll it to the market. We actually work hand in glove with our student. Here with me is Raymond. He's on attachment. He's doing mechatronics engineering. Maybe over to you, Raymond. You can just highlight briefly what you've been working on.
We're using this 3D printer to print objects like this from plastic. It uses a filament, plastic filament, which it uses my extruders to heat the plastic, and it comes in the form of this, and it prints this plastic. We can make this using SolidWorks on a software, on a computer. You can make any design, what you want, anything in your mind. As it is printing something like this. It is printing now.
So this is part of a transformer core. We are actually making transformers for our inverters. So instead of importing transformers, we're actually printing the components that will be part of our transformers. So as we go forward, we'll be making locally made transformers here at the Innovation Hub.
The implementation of Education 5.0 doctrine, which seeks to place universities at the center of industrialization and modernization agenda, is now bearing results. Chinhoyi University of Technology is leading the drive to create a knowledge-driven economy.
Card printing press started as an innovation which catered for the printing needs of the university. But due to the demand of the community in Marsh West, we saw the need to actually provide services to the external community. So now we're actually producing exercise books, as you can see. We're actually distributing in the schools, and we're selling to the other institutions, educational institutions. We also do complimentary cards, and we also do textbooks for the students, the internal and the external students, and the modules. And we also do like the booklets for the graduations. So this is our finishing section where the books are folded and stapled and pegged. Like the packaging you see here, it's actually done at this section. So we got
students or employees?
We've got students and some employees. We've got attaches, 2 of them, and the other ones are employees for card printing press.
So you're also assisting in terms of local employment in the local community?
Exactly, that is what I do. And actually, we actually train the students on the industrial processes of printing.
This new approach to learning and development of innovation hubs and industrial parks provides the basis for a stronger partnership between education, industry, and the overall economy.
This is our reverse osmosis plant. So this is where we actually do the purification of our council water that we get from here in Chinhoyi. It gets purified in the system. It is utilized as one of the raw materials for our other products, as well as our mineral bottled water project as well. So overall, the whole unit, we were actually very fortunate in that the ministry gave us the seed capital to begin the project. So the project began with preparing sanitizers with response to the COVID pandemic last year. And from the proceeds, or the profits rather, that came from that aspect of the project, we were able to get capital to reinvest into our reverse osmosis system. We actually purchased this particular plant, all the components that you see here, from the profits of that initial seed money from the ministry itself.
According to the National Development Strategy 1, government's vision is to equip graduates with skills that empower them to become innovative towards societal development through transformative science and technology knowledge application that delivers goods and services. The objective is to ensure that resources earmarked for research, development, and innovation will be availed in order to operationalize innovation hubs and industrial parks in institutions of higher learning.
We were resourced, we were given a lot of resources to start the innovation hub, to build the Agric Industrial Park, and also to purchase a lot of equipment that allows us to teach in a way that imparts skills to our students. And with the Agric Industrial Park, we've started producing goods and services, which is actually the main objective of Education 5.0.
The national restocking exercise has been given an impetus from impact of the Agriculture Industrial Park and synergies with the artificial insemination program.
After realizing, no, now this is coming from research, you observe in the communities, very small animals, we call them hard mashuna, most of the times. So you see these small animals, and then people begin to ask, if you ask the old ones, they will say, you see, a long time ago we used to have these big animals, but we don't know what is happening or what has happened to our animals. They are now very small, poor performance. But in science, then you know from what has been happening that inbreeding is one of the major causes. Of course, availability of feeds is also another contributing factor to the smaller sizes of our animals. So then we said, okay, so how are we going to help our people in trying to solve or dilute this problem of inbreeding. That is the reason why we came up with this cattle breeding project, which is now the national cattle breeding project for Zimbabwe. You know, the government helped us with financing everything that is happening here. They helped us with funds to buy a good genetic material. For example, we have now at present 9 beef bulls and 3 dairy bulls. So it means the farmers have 9 breeds to choose from. Obviously, these breeds are very expensive. You know, good genetics is expensive. So what we thought is the best to do is to get these animals and then harvest the semen from them. And then if a farmer would want to have the genetics, then we can do artificial insemination for as little as $25, $30, accessing good genetics.
Welcome to the Chinhoyi University of Technology Feed Factory. This is an output of our government support in pursuit of the Education 5.0 mantra that we are pursuing, where we are producing goods and services. So this factory started as a research where we are producing commercialized blocks which are meant to support ruminant animals, the beef animals, the dairy animals, the sheep and goats. And currently we have 3 products that are on the market. We have the summer block and the winter block for all ruminant animals. And the idea behind is to make sure that the animals, they are fully supported throughout the year so that they produce good milk and they perform well in terms of their growth performance. And we have also added a new kit on the block for our products. We have the game block now, the summer and the winter blocks, so that we also support those who are doing game farming.
The Director of Cattle Breeding and Reproductive Technologies at Chinhoyi University of Technology, Dr. Fungai Chatiza, gives an overview on the role being played by the institution in the National Cattle Breeding Project.
What this unit does is to collect semen from the breeding head, which is at the cat farm. We process it in the semen station, and then we take the semen and distribute it to farmers in Zimbabwe across the provinces for artificial insemination purposes. We are also embarking on a variety of research projects working with semen and oocytes, embryos, or just germplasm in general. We also have developed a semen bank which we're using for 2 purposes, one being your artificial insemination program, which we have started. To date, we have inseminated over 2,000 cows across Zimbabwe in the different provinces. We have capacity to produce over 1.2 million doses of semen or straws of semen. So our capacity and our intention is to supply semen to the local market in Zimbabwe and to export semen to our regional markets as well.
I am a PhD student with the cattle breeding project. My area of specialization is reproductive biology, and part of the work that I do is to freeze semen for evaluation from different breeds, different males, different bulls, and come up with new protocols on optimization of preservation so that we reduce the costs associated with cryopreservation, both to the station here and to end users who are the farmers who have their animals inseminated. So when we come from the farm, we have a semen sample like this one I'm holding. And before we further process the sample, we actually need to do quality checks on it to make sure that the spermatozoa are alive and they reach our thresholds in terms of quality before processing, and as well as to determine how many doses of semen we are going to make out of the sample. So we actually analyze for 2 main things, which are motility and concentration. And we also analyze for morphology, which we do a bit later. So we have here, we have a sample. So we actually use this machine, which is a spectrophotometer, calibrated for semen, to actually do the concentration. Once we do the concentration, the machine automatically calculates for us the number of doses that we can do. Then we take the sample to the CASA system, which is a computer-aided sperm analysis system, one of its kind in the country. With the CASA system, we check motility, whether the spermatozoa are still alive and moving, and what proportion of them are moving in a progressive linear fashion. We actually package the semen for freezing in a goblet like this, that we now put in a liquid nitrogen tank. So this is our sample, actually a sample of the semen actually stored in liquid nitrogen. So it's now stored at below minus 196 degrees Celsius in this tank. It must last indefinitely.
So we are now in our semen bank, which holds semen from the 9 breeds, about 16 to 20 bulls from the cat farm. So in here is semen from your Tuli, your Bonsmara, your Brahman, your Simbra, and so forth, and your dairy breeds. So from here, we then dispatch our semen to field for artificial insemination purposes, and then we also hold some of that semen in the bank for future, for research, or also for future catastrophes that the country may face. So this will become the repository or the backup for the nation for any breeding purposes in cattle. The semen bank currently holds bovine semen, but in the future we're looking to hold other species, your goats, your pig, your whatever other species of interest to the country.
The university has pioneered innovation which is bridging the gap between knowledge produced in lecture rooms and industrial production.
This guy is actually a third-year student under BSc Chemistry honors degree at CAT, and he is attached here, and he is responsible for the product formulation and the development. As you can see, he's actually trying to come up with a formulation for a new product in dishwashing liquid.
Students are able to see the application of the information and the knowledge that they're getting through the teaching that they're receiving. So the concepts that they're learning within their various courses are now being applied to produce products that people can use in their homes and in industry. So this is in response to the Education 5.0, and we have tangible outputs that people can see and relate with and purchase in our markets.
I think this is quite beneficial since it brings us to learn more of practical than theory. So now we are not only learning the theory, but now we are able to do practical things, like making the things we use at home, like dishwashers, like hand sanitizers, like disinfectants. Now we are being able to make practical out of these things.
As the country is making strides to fulfill the aspirations of the NDS-1, human capital development and innovation are key principles in creating right conditions for a knowledge-driven economy for sustained growth.
As you know, that Zimbabwe is blessed with a lot of minerals, so we want to make use of locally available materials to make jewelry, and we are also doing waste management, because as you shall see, some of the materials we have here, we are using cardboard boxes. We are also using some material, like cut-off material from clothing, those who are sewing clothes. So we are also, in a way, managing waste. We are also doing reverse logistics. So we want to equip women in the society with entrepreneurial skills. So that's why we are now using this innovation hub in order to impart entrepreneurial skills to women in the society. We have already found an export market for this jewelry. So we'll bring in the much needed foreign currency.
The COVID-19 season has brought a new dimension to business. For the institution, the new normal has offered new opportunities and new innovation to mitigate the effects of the pandemic and aid industry with solutions for sustained growth.
This project started last year in March in response to the COVID-19 pandemic. So we started with the production of sanitizers, and then later we diversified into the dishwashing liquid soap as well as disinfectants. But in the near future, we're also going to do bottled mineral water, and we hope in the near future we're also going to do more diversification in our products and make it more valuable to the community in terms of achieving a Vision 2030 as well as the NDS 1, NDS 2, which are related to the devolution program.
Last year, when we had the COVID-19 pandemic outbreak, we then tried to find ways in which the institution and the unit could also play a role in fighting against the coronavirus and its spread. So the first product which we came up with were the face mask, the clothing face masks. So from then, the unit has been growing. We're looking at more products to deal specifically with the health sector. We are now producing a range of products from reusable cloth face masks to PPE, which can be worn in surgeries or theaters.
The government, through the Innovation, Science and Technology Development Priority Program, is focusing on the innovation type of industrialization to act as a conduit for universities and colleges to innovate products based on Zimbabwe's natural heritage, which promotes import substitution and domestication of value chains as pillars for industrialization and modernization of Zimbabwe by 2030.
So what we are seeing here is we are completing the story by integrating usage of waste from all our units, from animal production, piggery, dairy, cattle breeding, as well as waste that is coming from our kitchen. We are also extending further to utilizing waste from our Chinhoyi municipality, mainly from the fresh vegetable market. So here we are utilizing a very wonderful insect pest called the black soldier fly. This is, as you can see, these are the larvae that we use to produce protein. Let me give you a little bit of background. In animal feed production, the main source of protein is soya meal. If you're producing chicken, pigs and so forth, you are using soya, and soya is imported, and per month we are importing up to 4.8 million worth of soya from outside the country, and this is quite a big cost on us. So what we're saying here is we want to reduce that import bill by utilizing and integrating this wonderful insect, which is a very good source of protein. On composition on dry matter basis, once dried, this insect is 65% protein on dry matter. And in addition to the protein, we also have vital fatty acids that are also important in feed manufacturing. So our story here is we're not going to waste anything on the farm. We are going to farm proteins using waste and integrating other farming activities. So there we are with the black soldier fly. These are the larvae, the maggots. They are wonderful. As you can see, these are the remains of a harvest from a cabbage farm. And we are not, instead of leaving them lying out to rot in the field, we are bringing them here, and our maggot does a wonderful job. Yeah, it converts this into a very high value product, which is a protein, and in addition, it turns it into a very valuable source of manure that we can either harvest in the liquid or in the solid form. So out of these bins that you see, each compartment has potential to produce 300 kilos of fresh maggots in 21 days. And we have 12 of these lined here. Within 1 month, we have a capacity to produce 1.2 tons of larvae or of maggots. And this is valuable because we are saying it's 65% protein. This can translate into a big tonnage of feed once we eventually formulate the feed. And we are operating on a small piece of land. Let's compare with soybeans production. We need thousands of hectares, a lot of effort, a lot of machinery, rainfall, irrigation, and so forth. But here we are doing on a very small piece of land within a very short period of time. We are substituting imports of soya, but we are also complementing by utilizing the waste. This technology can be done at both small scale and at large scale. At the moment, we have done a modeling trials with up to 2,000 farmers, small-scale farmers, who have shown a lot of enthusiasm and potential to produce these maggots at their homesteads. But going large-scale into the large corporates that want to produce these maggots, this is also very possible. If you put the right investment, the right structures, we can go up to 10 tons of maggots per month. And this is very good to support an industrial scale production of feed.
Human capital development and innovation are the engines which will drive NDS1 and the country's progression towards Vision 2030.